Hi, welcome back. In this lesson offered by SimplyLearn, you'll learn about scientific computing with Python. In this lesson, you'll learn why SciPy is required and its uses. You'll learn the characteristics of SciPy. You'll get to know the packages of SciPy. You'll also learn the subpackages of SciPy, such as optimization, integration, linear algebra, statistics, weave, and I/O. Scientific Python, or SciPy, is an extension of NumPy for scientific and advanced mathematical algorithms and functions. But why do we need SciPy? Before we learn about it, let's get ourselves familiarized with some real-world scientific domains and the extensive work involved. A few are listed here. Statistics. It's a domain which helps scientists build a hypothesis and predict the outcome. This is an important analytical process in data science. Spatial data. In this domain, scientists study spatial data structures. Spatial data consists of spatial objects made up of points, lines, regions, rectangles, surfaces, volumes, and even data of a higher dimension, which includes time. Examples of spatial data include cities, rivers, roads, counties, states, crop coverage, and mountain ranges. Here, the major task is to retrieve records based on some spatial properties. Image science. This domain covers the study of multi-dimensional images and its processing. The main task here is to understand image properties and extract values from there. Mathematical equations. This domain is used to solve bigger or complex problems, such as integration and differentiation functions. Platform integration. Different platforms that are built on languages such as C++, MATLAB, and so on need to be integrated. The main task here is to reuse the code written in C or C++. Signal processing. It's a scientific method for signal processing such as analog or digital. The main task here is to read and understand the signals from electronic processors or electromagnetic waves. Optimization. It's a scientific process to choose the right values from a given set of values. The major task here is to improve the overall performance of the process or system. SciPy comes in useful to deal with the tasks of these multiple domains. It's a Python library which has built-in packages such as mathematical integration, linear algebra, statistics, language integration, and image processing. We'll take a look at SciPy in detail in the upcoming screens. Let's look at some characteristics of SciPy. It has a huge collection of built-in mathematical libraries and functions to support complex scientific computations. The high-level commands and classes make data manipulation and visualization seem easy. Since it's built on top of NumPy, the data processing is extremely fast and efficient. It integrates well with multiple systems and environments. It has a large collection of subpackages for different scientific domains. Its developer-friendly libraries and functions simplify scientific application development. This screen talks about the subpackages of SciPy. We'll learn more about the widely used packages such as integration, I/O, linear algebra, optimize, statistics, and weave packages later in this lesson. We'll also focus on linear algebra and statistics. Note that you can check what is provided in the package with the help module function. Let's briefly go through the list of subpackages. Cluster. This package helps handle cluster algorithms to find the right pattern or target in the data. Constant. This package is used to perform mathematical equations such as pi. FFT. Fast Fourier transform, or FFT, refers to a way the discrete Fourier transform, or DFT, can be computed efficiently using symmetries in the calculated terms. Integrate. It's mainly used to solve mathematical sequences, series, or function approximation. Spatial. Spatial data structures and algorithms are mostly used in problems related to graphs. Spatial data is used heavily in systems like GPS. Interpolation. It's used to create new data points for the given range of values, lower limit and upper limit of functions. Input and output. I/O in SciPy has many modules, classes, and functions available to read data from and write data to different file formats. Linear algebra. This package is used to solve linear algebra problems. ND image. It contains different functions for a multi-dimensional image processing. ODR. It's the orthogonal distance regression package called SciPy ODR. This package can handle both explicit and implicit function definition. The optimize package. This package of SciPy is used to optimize the process performance by fine-tuning the process parameters. Signal. Signal processing is an enabling technology that encompasses the theory and application of processing or transferring information in many different formats broadly designated as signals. Sparse. It's a two-dimensional sparse matrix package for numeric data. Weave. The SciPy Weave package provides tools for including C and C++ code within the Python code. Stats. The stats package contains a huge number of probability distributions and a growing library of statistical functions. Special. The special subpackage is used to retrieve other special functions in SciPy.